Let's look here at writing and using system of inequalities from a word problem or an application problem. All right, so what we're going to do here is Mr. and Mrs. Rodriguez are driving across country with their 2 children. Maximum of 10 hours per day that they're going to drive. Mr. Rodriguez wants to go 4, but at least 4, but no more than 8. Mrs. Rodriguez between 2 and 5. And we are going to write and then graph a system of inequalities. And then we're going to show 4 driving combinations that reach their 10 hours. Let's straighten up these lines. Not really. I am going to show those in a different way. Max of 10 hours, at least 4, no more than 8, and between 2 and 5. So let's determine here what variables we use. We could use, well, M and M don't work. Father and mother could be used, but that gets confusing. So I'm going to say that Mr. Rodriguez is X, Mrs. Rodriguez is Y. So X stands for Mr. Rodriguez, right? Oh, it looks like it's a Q, not a G there. So it's going to be Rodriguez. And Y is going to be Mrs. Rodriguez's hours. And I should put hours of driving. Hours. Okay, now that's a little bit clearer, hopefully. So the easy one here, there's a maximum of 10 hours. Maximum means 10 is the most, but you could have less. So we can say his number of hours plus her number of hours has to be less than or equal to 10. Then we're going to say that because his is at least 4, no more than 8, so X is greater than or equal to 4, less than or equal to 8. And hers are going to be 2 and 5, less than or equal to, and less than or equal to. Okay, now we're going to graph them, but we have to set up the graph. So since X's are usually in the bottom, I'm going to put 0 there. I'm going to say that for the X's, that's Mr. Rodriguez's hours. Hours. Ooh, this is not printing out well for my me. So let me make it a little larger. Mr. Is hours. I think I have to put Z is like an S and just put an apostrophe, I think. And then here, this will be, this is Rodriguez's hours. And we already know the maximum for anyone, even total driving, will be 10. So let's go and make 10s. Oops, one at a time here. Why I put that one there? 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you draw or set up the graph in a way that makes some sense here. And since I chose X and Y, that makes which side is which. But then the numbers I see probably make the most sense going up to 10. In a different problem, I choose different numbers and separate them out with spaces correctly there. So this one is easy to graph right now, and I'm going to do it by changing it into slope-intercept form. So if I subtract X on both sides, I get Y less than or equal to negative X plus 10. That gives me a y-intercept of 10 and a slope of negative 1 over 1, which gives me these points all the way down to here. So that now I can graph that. This is a place where, oh, if I put arrows, wait a minute, that doesn't make sense. I'm not going to go to negative driving time, and I'm not going to go past 10 driving time, because the problem clearly says it has to be the maximum of 10. So this is the appropriate place to not put arrows. In fact, if someone did put arrows, they would be wrong in doing so because it's not appropriate for the situation. Now let's graph this one. How in the world did we graph one where the x is between them? We need linear equations, okay? The way to do that is to separate first this one. Do that is x is this, therefore greater than or equal to 4. You can do that if you keep the inequality sign facing towards the right things. So the less than part is towards the 4, and the greater than part is equal to the x, so I just set it up that way here. Next, now, okay, I wanted to make sure I got 4. Now we'll do this part, which is x is less than or equal to 8. And then we'll do the same things here. So first we'll do the x greater than or equal to 2. Oh, wait a minute, watch out. That's not x, that's y, because that's for Mrs. Rodriguez's hours, this one here. Between 2 and 5 is for Mrs. Rodriguez. So it's very important to get the y there. It's very easy to make a mistake and put x instead of y like I did. So let's now fix that. If you had the x incorrectly, please put the y. And now, so now I have the greater than and equal to 2 and less than or equal to 5. So we actually have 1, 2, 3, 4, 5 different ones that we're going to do. We just did one of these. So this one's done. All right, now I'm going to do the other 2. And so I'm going to do x is greater than or equal to 4. Okay. So that is a vertical line. Oh, but no arrow. There's no need for an arrow. If it was just that, we could say, I guess we could put an arrow in this case, but it won't be part of the final thing. So that's x is greater than or equal to 4. Ooh, now I'm realizing I should do some shading. If it's greater than or equal to 4, it's going to be shaded this way. Let's go back to the other one, less than or equal to 10. So if I pick a point like 0, 0, and I plug the zeros in, 0 less than 10 is true. So that means this one's being shaded here. I think I've got too many blues in there. So I think I'm going to shade with something else. I think I'm going to use the green so that it doesn't get in the way with the blue lines. And this one's here. So if it was just those two, we'd have a shaded area here. But we need to do the other one. So I just did this one and this one. Now x is less than 8. And so for that, I'll come over to 8 and I'll draw this. Well, I think I will need to use this to draw a better straight line. I did it with a 4, but not good enough here. Okay. And for that one, it's all less than that. So that keeps it just these areas here. And now let's do this one, greater than 2, and that's a y one. So we go to where 2 is, draw a line here. Not quite on it, but good enough for it. And it's greater than, so that means we're doing up here. So we still have only this area that can be shaded right now. And then we have to have y less than 5. So 5 is here. So I'm going to do y less than 5. So the area where all of these match all at the same time appears to be this. I want to play within the lines a little bit better. So what that means is only the area that's shaded solid green right now has points that would match all of these. So the points that are in here, and I'm going on the actual, oh, it's equals to. So every one of these where there is an intersection, because they're all equals, that means all those points are good too. So we have numerous points where it's full hours. So let's take this one here. That would be Mr. Rodriguez driving 6 hours and Mrs. Rodriguez driving 3 hours. And that would match this where X and Y, 6 and 3 is less than 10. 6 and 3, if we add them, wait a minute. Oh, the 6 is in between 4 and 8. The 3 is in between 2 and 5. And every one of those would be true. However, the thing we have to think about is the last part of this. Show from the graph 4 driving combinations which would reach their 10 hours. So that means it has to be 10 hours there. Well, that means here it has to be on this line because this is an equal line. So this is 1, this is 1, and I'll do a double circle around those. So those ones, the first one here is 5 and 5. So 5 for one and 5 for the other. Then 6 and 4 for the next one. That's this one and this one. And then this one is 7 for Mr. Rodriguez and 3 for Mrs. Rodriguez. And then this one is 8 and 2. Now, so those are the 4 points for part 3. However, for this kind of a thing, you can't give the points. What you have to say is they can drive for Mr. and Mrs. Rodriguez. Figure out how to say it. We have to put it into some type of phrase or sentence. And so I'm going to try to fix it. 6 and 5 hours for 6 and 4 hours for 7 and 3 hours for 8 and 2 hours respectively. Let me see if I can get that out. Respectively, meaning respective to the order they are. He's first and he's second. And I realized I need to be consistent. If I'm writing the word and each time, I need to do it for all 4 times, not just 3. So that would be the answer here. So it would be 5 and 5 hours, 6 and 4 hours, 7 and 3 hours, or 8 and 2 hours. And the whole answer would encompass that. And you can see graphically why it's so, because we have these points up here on the graph. And we got them by making inequalities like these. So we made these inequalities, and then for 2 of them, needed to break it down even further. And then we had to shade different sides. You could see that any of the points there would satisfy all the inequalities, but wouldn't satisfy the part 3 of the answer. But now we have a good answer. Okay, so I'm going to fill in more of this yellow and say we have successfully used inequalities to solve this application problem. Yay. All right. And it does make sense when you think about those solutions that are there. It passes the like common sense little mental test people should do whenever answering these types of problems. Hope that helps to do this type of a problem. Thank you for listening and watching.